If your brain's getting a little fried, stick with me for a little bit longer. We've got one more thing to talk about with motionlessness, which is actually surprisingly fascinating. I want to point out one thing from before. An object that's motionless or at rest, well, from a force point of view, it's in the exact same situation as an object moving at constant speed. So from here on out, whenever I talk about an object that's at rest, we could also be talking about an object that's at constant speed. It's just a little easier to visualize an object that's not moving. And the key to motionless is realizing that when an object is at rest, its acceleration is zero. F equals ma tells us that zero acceleration means zero total force. Zero total force doesn't necessarily mean that there's no force acting on an object at all. All it means is that any upwards forces must be balanced by corresponding downwards forces. Likewise, leftwards forces must be balanced by rightwards forces. Let's take a look at Ayush and Brent, who are each pushing on this cart. This cart has mass m, and we'll say that the mass is 5 kilograms. And right now, the cart is exactly at rest. They're both pushing very hard, but the cart is at rest. I should mention that most of these questions we do, we're going to ignore something called friction. Friction is the force you feel between your hands when you rub them together. It's a real force, and it's something we can talk about, but to make matters simpler, we'll often ignore it. So this is a frictionless world for now. So let's go ahead and take a look at all the forces acting on this cart. I'm going to draw a force diagram. Well, the first force I'm going to draw is mg. And in this case, mg is going to equal this 5 kilograms times g, and we know g is 10 meters per second squared, which gives me a total of 50 newtons, and newtons are the unit of force. The ground must also be pushing upwards with a normal force. Ayush is doing his best, and he's pushing to the right. We'll label that Fa for Ayush. And Brent is also doing his best and pushing back to the left. We'll label that Fb. Notice how I've drawn these arrows. Even though Ayush is pushing from the left to the right, I don't draw an arrow like this. For me, it's much easier to see what's going on if the arrow is coming from the object and moving out. So we know that the cart is at rest, and I've given you a couple of the forces. I've told you that mg is 50 newtons, and I've told you that Ayush is pushing with a force of 100 newtons. Can you use this data, as well as what we learned up here, to fill in these two answers?